Hello, everybody. In today's package resolve for Playdate journey, we're going to keep going with our port as we now enter the stages of Draw the Rest of the Owl. Who knows what that's going to look like? I have an idea, may not be the only one though. Hello, everybody. Looks like I don't have any viewers at the moment. That's fine. That's fine. Or maybe I do, and I just don't see anyone. Dun dun dun! Who knows? Who knows? Alrighty, so let's go ahead and kind of get started then. So let me just make sure I switch to the correct one today. There we go. Okay, I remembered. So as we kind of alluded to before in our discovery tree here, we are now in the Draw the Rest of the Owl stage, which, suffice to say, very interesting, as I may not know entirely what that looks like. I did note down like a couple of things that I wanted to consider when going through this. Definitely addressing the remaining parts of the core gameplay loop, such as having a rolling background, like where you actually collect the boxes and then a timer. Obstacles is also another thing too, which I probably should add in here as well. So let's just kind of move that over. Obstacles. Alright, because that's the main basis of the game right there. And then just some QOL stuff, which we'll probably take a look at some point. I'm not sure if we'll get to them now or later, but they'll be there, ready for us when we get started. Now, this is the part where I be honest. I know the first couple of streams it did feel more or less planned because we were like, okay, we're gonna do this and that and this and that, because it's like addressing the fundamentals. But we're at the stage now where at this point it's just whatever. So if we end up going down completely random rabbit holes, that's what it's gonna be. So I think probably the first thing that we'll do before we actually address anything in our tree here is actually take a look at what we're going to be doing, or what the current state of our code base is. So let's kind of switch back here. I was trying to work on some stuff, address a little bit of concerns with the movement. That didn't quite come into fruition though. So if I were to just run the simulator, again, just to kind of revisit what we have the bird, and you just kind of move bird around with the crank. I mean, the crank here is just a rotary circle, but like you can actually imagine the actual device here. Actually, oh, I'd have to get up for a cable. I didn't think that part through. We'll just pretend for the sake of this that it runs on the device. Right, you would just use the little crank here, up and down. If you want to imagine it like simulator side, like you're viewing it this way. Right, where it's just rotating in a circle. That's as far as we got. So now we're just going to need to figure out just kind of the rest of everything, really. So I guess let's figure out what we can start on. I'm not sure if we want to do the rolling background just yet, because that requires me to get some art done, which, I'll be honest, I didn't spend any time last night doing, which I would have done to prepare for the stream. But in that case, oh, why are you acting funny now? Oh, I think it's because the simulator's open. Okay. Yeah, so I think maybe what I want to do is start with the timer. only because I think that'll probably give us a good indication of, or we could do the boxes too. At least getting those addressed onto the screen. Yeah, I mean, I suppose we could get started with this, right? Do some box collection. So what that probably means is we're probably going to need to move some things around. I still don't like in particular that we just have this large chunk of code here handling all this. In some case, I would want to move some of this stuff out just to make it cleaner, but it is what it is. We'll work with it for now. Yeah, so we're probably going to need some boxes to work with. Now, the thing is, right, and this is going back to the game here, right, so if we were to pull up our reference material, disable that, and here we just kind of get an arbitrary number of boxes that spawn. I don't remember if this is actually deterministic, in which I have a set number of boxes that spawn, but in any case, I do think I'm going to need to implement something like that for the game, because I think having dynamic amounts of boxes just kind of randomly scattered will be a little bit tricky to work with. And also I want to be as conservative with memory as possible, so yeah, let's actually take a look at the source code behind this. I want to recall if we managed to do that. I think I have the source code linked here, right? Yes, I do. Wow. Okay, game scripts. I think it may be in the game loop. Make pickable, yeah. Place pickables. Okay, so it is a set amount. 8 specifically. That's fine. Okay. That makes it easier for us, because then that means that we have a specific specific thing to work with there. Okay. So I guess for now, let's I think this is how we do it. Or no, I think we need to do boxes equals like that. And then in our init loop, we'll actually go and modify that. So fill boxes for I is less than 8. I think we can do operators here. Yeah, let's do this. Boxes I is oh, I think that's just rainbow brackets. feels a little cheesy doing that. Let me actually check to see if that's how you do that. Oh. Oh, okay, I don't think you can actually do that. That's fine. Can we then do printf? I mean, I think ideally what we should do instead is have this as a testable function. Yeah. So let's move that into Charlotte. New file. H, define boxes H, end if, include vector dot H, and then we'll do a void fill. I think we can do that. I don't know, we're gonna have to check. And then after that, we also want to put the amount. Because I don't think we can grab it from here. Yeah, okay. Okay, so let's go to our make file and add this as well. Test dependence. Oh, you know what? We haven't actually included this into anything yet. So let's actually create the boxes.c thing here. Include standard lib. Include vector.h. We're just going to take that. For now, it'll do nothing. Right? Yeah, okay. And then we need to go to our test.c to also include that in the boxes here. Yeah, okay. Great. So now we do need to specify that. We won't touch the main one yet. Because for now I want to test whether this will actually execute. Note, include the header. Oh, this needs standard IO. I forgot about that. Okay, yeah, it's complaining right now because I think the test for this is old. Yeah, okay. I forgot to revert that back when I was testing some stuff. I had to write a approximation function because I forgot that C didn't have an approximation thing. Or at least to my knowledge. So I guess let's write another unit test for this. Unit result test box fill const unit parameter params void data. Okay. So we'll create a new boxes array. Don't we need to specify a size? I don't remember. Do 3 nulls in a row. Okay. And then we're going to do fill boxes int 3, and then we want to do just to grab a random one for now. Oh, hold on. Aren't we able to do a not nil or not null assertion? Yes. Boxes at 0. You could be a little bit, yeah, let's be a little bit more fancy about that. For int I 0, I is less than 3, assert not null, boxes at I. And so then, if we were to run the oh, you know what? It doesn't like that. I think I just need to do that. Right. vec2f3. What's going on here? Note call to undeclared. What? Incompatible type. Oh, is the signature wrong? Maybe I don't even need the thing. Assert not null, assert true. Okay, so now we're going back to screaming about this. Lovely. Const void. Incompatible type. Oh, do we need to pull it out? Box, we'll say. See if this fixes the issue. No, it does not. Const void star. Okay, let's rewrite the test a little bit differently then. If box is null, Then I think there was a way that we can assertions. Yeah, okay. Return M unit fail. Try that. Invalid operands. Fine. Invalid operands to binary expression, float, void star. I must be stupid. See. Check array not empty. This is gonna be so stupid. Size of the array. Okay, I see. I see. Okay. We can do that. We can do that. So we can say let expected size equals size of a vec2f. Multiply this by the number of elements. Unit assert int. So expected size equal to. Oh no, we want size of boxes here. And then we come here to the expected size, I think. And I think that's what's going to enable us to let. The Swiftie in me, apparently. Okay, so at least now the tests run. Then we'll return a value there. Okay, so now I think we can add this to the list here. Charlotte, what do you call test box fill? So we can just say fill. And then the actual method itself, which is test box fill. We have no setup, no teardown, option none, and no parameters. And we'll just do that, and now our test should run. Filled. Okay. Okay. That's spooky. Fine, let's do this then. change you to be size of dummy boxes. Does this need to be size T? Tests are passing when they shouldn't be. That's not particularly promising. As we have mentioned the size of the array. Check array item not. Yeah, array item exists. In the static size, you can get the length of the array via size of. Yeah, I mean, that makes sense. It's within the bounds. I mean, we could try that. We may not even need the dummy boxes then. So, let's get that then. Length is size of array divided by the size of, not int, we want a vec2f because we're storing positions. Divide by element size to get the count. Int array 30. Oh no, we don't want to pass array here. We want to pass boxes. So then we want to say length 3. Switch this back to int. No, we're still okay, and I think it's because this is being allocated. Yeah, because the size is... What if we just did that? Needs an initializer. Oh, well, that's still... Let's comment out the fill method. Oh, boy. We haven't even done the fun stuff yet. You have to store the size of the array after it is declared. Yeah, we know that. Check array element. Yeah. Element is null. Array of 3 empty pointers. Yeah, that's what we thought. No, no, no. Maybe it's just being stupid. I is less than 3. Okay. Now, if boxes at our index is null, then we're going to return m unit fail. Initializing float with an expression of incompatible type void star. Initializing float. Oh, okay. That's interesting. Oh, okay. That still works. No, wait. Hold on. Incompatible pointer types. It's a parameter void. C initialize empty struct array. Is that what I need to do? Do I just need to do... braces around scalar initializer. Oh, do you not like that? And change this back to vec to f. Oh, you know what? Maybe it was because it wasn't a pointer. Yeah, that's what it was. Okay. We didn't declare it as a pointer. Whew, okay. So that means we need to go back to boxes to change that. Okay, we're good. We're good. Okay, so that means that we now have the test set up and the test fails successfully. That sounds so weird when I say it, but it's the way TDD goes. Okay. So I guess let's implement this for int I is 0, I is less than the quantity, I++. I think we could just say boxes at, for now anyway. And then I think that does it. Expected expression. Well, that's not particularly great. Vector is 0.0, 0.0, and then we just say vector. Assigning vec to f with an incompatible type. Error initializing double. Why do you think these are doubles? Okay. So then, I think what we can do is we can have the randomness of where it actually lands. So then let's actually pass that in. So float should be the randmax include, and I think we're going to need the math.h library here. Float expose will be do we not have a random? Float rand. Okay, so we do call rand. I was at least right on that. So we cast it. I guess we don't even need math.h. What are we doing? And then they divide it by, what is a here? Where a is some float divided by a user. Okay, I see. Divided by float rand max divided by our defined rand max, and then we can say that this now becomes our x position. This should work. So then let's update the test to also encounter unit assert float boxes I dot x. May need to do a dereference. I doubt it though. We'll see. And then we just need to update the parameter to 400. Too many arguments here. Oh, you know what? Because I didn't update the h. Silly me. Member reference. Did you mean to use? Let's go. Let's go. I remember how to see. Sort of. Okay, that's good. That's good. This is very good. So let's kind of document what this does, just real quick. Fills an array of boxes with random positions. And parameter boxes, the array of boxes to fill. Parameter quantity, the number of... I can't spell for the life of me. The number of boxes to fill in the array. Rand max. The highest, or the maximum position on the x-axis possible. Okay. So I guess now we can go back to our main C function and do this. Right, get width, get height. Boxes, or no, we want to call, oh, we don't have the fill imported, but that's fine. Good, good. Do we have this added to the source one? I'm starting to notice that some of these have the same things going on, so we may want to move that out. Maybe. Yeah, we could. Charlotte vector C here. Yeah, okay, that works. So now we just need to declare that here. I think that should still compile. We'll see. Unit tests are still good. How about the game? The game still runs. Excellent. Great. Okay. So I guess back to the main then, we can import that. Fill boxes 8, and then screen bounds dot x is what we want. That just runs the unit tests. Oh, the sim crashed. It didn't like that. I suppose we could just call it again. I don't really like that though. No, that just straight up crashes. This might be shadowing another name, now that I'm thinking about it. Yeah, let's try that. I'm gonna do a rename. Go back to the test. Boxes here. Yes, yes. No, didn't quite like it. Yeah, so it really just does not like our filling, which I find very interesting. So then, how do we fill it? I mean, I suppose we could try putting it in a later stage, but fill boxes. Let's check my tests. No, we don't need a... Oh! Oh, I know why. Yeah, that was it. We forgot to give it the size. So let's try to fill into a completely empty thing. Okay, well that is good. So let's commit this. But I am also realizing that it's not just the X position that matters. It is also the whatchamacallit. Right, because we also need to display them on a different thing vertically too. So right now, if we were to just actually draw the characters, they'd all be on a straight line. So we do need to modify this just slightly. So I think we can get away with just using another vector to set the bounds instead. X. And then what we need... so I guess we'll say a float step is bounds.y divided by the quantity, because that's how much we're going to need to increase. And I think we could just say, well, no. We need to figure out what... Oh, I know what we could do. I think we could just do step times float of I like that. So then we just need to change the U. Bounds the maximum boundary for a given position. And change U to bounds. There's probably official C-style commenting that I'm just not aware of here. But we're rolling with it. How about that? So we need to change this part as well. Vec2f bounds is 400 F and 240 F, right? And unit assert float boxes I of y is less than or equal to 240. Oh, we need to run the unit test, not too few arguments provided. I was wondering why it was slightly off here. Fill boxes 3, and then we pass in our bounds. Okay, so the test pass. Let's go back to the main file. And that means we can actually remove this and just replace this with screen bounds. Why did I run the unit test? We already verified that the test. Okay. Excellent. I mean, we can't actually see the changes, but at least we know that it's working because of the unit test that we have, right? Which is the important thing. And that's why I try to focus a lot more with test-driven development, because at least if I can't visually see the changes that they work as intended, at least I have unit tests written as a backup here to at least verify that the code is working as I had intended it, even if I can't see it. Which is pretty important. Now, I think what we can do is at least we can start rendering some of the characters out. So we'll probably have to dig up the Hello World again to remember how to draw a font onto the screen. But at least we're getting somewhere. So let's try that for int I is 0, I is less than 8 I plus plus. Actually, while we're at it, let's define boxes count to be 8. Because we know that's going to be constant. We don't need to be too fancy about that. So what we need to do is dig through our source code. Wow. Check in here. We got 5 minutes. Let's see if we can whack this out. So we'll go to... We need to go to an older commit, I think. Here. We go here. Reformat files, update, create hello world sample. I think this is it. Here. So if we were to look... Yeah, this is what we want. I'm just going to yoink that. We're going to use 0, I guess. String length of 0 with ASCII encoding. And then we're going to do boxes of i's x. And we're just going to do the same thing again for y. Oh, you know, I think this is happening in the wrong spot. Interesting. We're all up in the top corner there. That's not what I had intended. If we were to replace this with A, do we get the same issue? Yes, we do. boxes I X, boxes I Y. And if we were to look at our console, they're all zeros. Huh. I think something's wrong with the random logic. No, we're still all zeros. Why is that? Okay, here's an idea. I'm just going to strip that real quick. Oh no, we're still all zeros here. Interesting. Very interesting. I'm going to note this down. And I think just to catch myself, we need to change this part around. Right, so this needs to be 240 divided by 8. Times I. Oh, you know what? First off, that's not the amount. It's that. Okay, here we go. Okay. That at least sets us up for tomorrow. Try to randomize positions. Currently all set to 0, 0. Tests have been updated, but implementation needs to be fixed. We got a long road ahead of us. Okay then. So yeah, so I guess what we're going to need to do is, let me also note this in the tree real quick. Can I move you down? Yes, but we now have a random ugly line here. Box array. Fill with random positions. Yeah, so this is not ideal, certainly. I just want to check, because I think in our key, no, we don't have a block, we just have plented. Okay. So, that's a little funky, if you ask me. So yeah, I guess the first thing that we're going to need to do is we're going to need to do that. Actually, let's actually change some things around here. And I think we'll use a... to indicate that we're blocked here. Okay, so we're kind of blocked on that. and we're just going to need to figure out why the code's just being a little funky. I may try to do that off stream just to move us a little bit further ahead, but not going to be anticipating much there. In any case, I think that's where we're going to end it today. Happy coding, and see you again next week.